Hello friends, I am Jagishwar Singh. Now I am here to explain about black box testing. Black box testing. Black box testing is performed on the basis of functions or features of the software. In black box testing, only the input values are considered for design of test cases. The output values that the software provides on execution of test cases are observed. The internal logic or program structures are not considered during black box testing. It is also known as behavior or functional testing. There are a number of black box test case design methods: equivalence class partitioning, boundary value analysis, cause-effect graphing, error guessing. Equivalence class partitioning. Equivalence class partitioning method allows to partition the input domain into a set of equivalence classes. The equivalence class partitioning method has the following two aspects: design of equivalence classes, selection of test input data. Design of equivalence classes. The design of equivalence class is made by splitting an input domain into several equivalence classes, and these are expected to have different behavior. Selection of test input data. The selection of test input data has two ranges for each equivalence class, that is, valid inputted, invalid input data. The valid input data belongs to the range of equivalence class. Boundary value analysis. The boundary value analysis is the special case of equivalence class partitioning method that focuses on the boundary of the equivalence classes. It is generally observed that the human may make mistakes at the boundary level. Boundary value analysis is based on the idea of equivalence class partitioning. The boundary values are identified by relating the elements of input domain. For example, relational operators such as less than, greater than, equal to, etc. can be applied to relate the boundary level elements. Some of the boundary conditions can be zero or negative values, empty files, missing files, sequencing errors, invalid number of parameters, data ranges, etc. And therefore, the boundary conditions are verified to ensure the correct outcomes. Test data are selected in such a way that the boundary values will appear in at least one of the test input data. Cause-effect graphing: the main drawback of equivalence class partitioning and boundary value analysis method is consideration of a only single input domain. Cause-effect graphing technique begins with finding the relationship among input conditions known as causes and the output condition known as effects. A cause is any condition in the requirement that affects the program output. Similarly, an effect is the outcome of some input conditions. The logical relationship among input and output conditions are expressed in terms of cause-effect graph. Each condition, either it is a cause or effect, is represented as a node in the cause-effect graph. Each condition has the value whether true or false. The requirements are the basis for designing the cause-effect graph. The system is expected to perform tasks as it is intended. Error guessing. The error guessing technique is based on guessing the error-prone areas in the program that might be done by the programmer. Error guessing is an initiative and ad hoc process of testing. Software testers use their experiences and knowledge to design test cases for such error-prone situations. Let us discuss some of such error-prone situations. The Boolean variables have the values true 1 or false 0. There might be the chance of alternation of these values from 1 to 0 and vice versa. The null position is another error-prone area in the program. Thank you.